Now let's have a look at question 2. We've got to explain why force is a vector quantity. In your answer, you should use the appropriate technical term spelled correctly. Well, why is force a vector quantity? It is a vector quantity. So force is a vector quantity because it has both direction and magnitude. Nice easy one to start with. And now we know why force is a vector. I suspect we're going to need to know that in order to answer this next one. So part B, we've got figure 2.1. We've got forces acting on a drop of water on the windscreen of a stationary car. So we've got the weight of the object, there is a normal reaction force, and there is a frictional force holding it. So it's not moving, it's not accelerating. We're told that the windscreen is at an angle of 30 degrees to the horizontal. The weight of the water drop is 8.0 times 10 to the minus 5 newtons. The normal contact force is R, and there is also a force F acting on the water drop as shown. And the water drop is stationary. So let's have a look at what they're going to ask us next. And what we've got to do is use our figure 2.1 to determine the component of the weight of the water drop that is perpendicular to the screen and parallel to the screen. So let's just draw out my weight. So I have the weight acting down there, and it's asking us to look at it in terms of its two components. So if I just get a different colour, let's go for a red. What's close enough to a red? So what I could do is I could describe this weight as being made up of a component that is perpendicular to the screen and a component that is parallel to the screen. And as with all of these kind of questions, the trick is to realise which of these two is the angle that is given. So this here is the 30 degrees. Which one of these two angles here is the 30 degrees? And it is that angle there. So there's my 30 degrees. How can I tell that? Well, if there was no angle here, then, and I was to draw this out, so if I draw it out so it's a very, very small angle. So if the windscreen was at a very, very small angle, then that would be a very small angle, and that would be coming down the screen. So this is a very small angle here, so this one corresponds to this angle here. So that's how I can just check on that. Now I know that my weight here is 8.0 times 10 to the minus 5. So if I have a look, if I go parallel to the screen, well, that's using, this is this one, which is opposite the angle. So that's going to be my sine theta. So this one is going to be 8.0 times 10 to the minus 5 times sine 30, and perpendicular to the screen is going to be this, and that's going to be 8.0 times 10 to the minus 5 times cos 30. When I put those two numbers into the calculator, my perpendicular one will come out as being 6.9 times 10 to the minus 5 newtons, and this one here will be, not 8.0, 4.0, because sine theta is a half. Sorry, sine 30 is a half. There we go, question 2 done. And by done I meant that particular part of the question, because obviously we've still got part 2 to do, where we need to determine the magnitude of F, which is this one here. Well, and we've got to explain our answer. So if we recall from the previous part, when we split the weight up into its components, into parallel and perpendicular to the screen, we got that the component of the weight was parallel was 4.0 times 10 to the minus 5 newtons, and 6.9 times 10 to the minus 5 newtons, and therefore the magnitude of F, well, F is also running parallel to the screen, so I would say that the magnitude of it is 4.0 times 10 to the minus 5 newtons, because the object is stationary, or the raindrop is stationary, and so stationary, so the net force parallel to the screen must be 0. Now I have definitely finished this question.